Sathyabama Institute of Science and Technology.
Hello everyone, I am J. Karthika, Assistant Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. In this session, we are going to discuss about the topic Apache Flink. Apache Flink is a data processing tool which combines the strength of both batch processing and stream processing. So, in this, first of all, we are going to see what is batch processing and what is stream processing. Batch processing is a collection of data, sorting it, and then we are going to process a set of data as a batches and then processing it multiple times to produce a results. Here in batch processing, it deals with discrete data, that is data at rest. So next one is a stream processing. Stream processing is a continuous data, that is data in motion. So batch processing deals with discrete data, data at rest. Stream processing deals with continuous data, that is continuous data in a sense it is a real time data. So data in motion. So Apache Flink works with both batch processing and stream processing. It takes the strength of both batch processing and stream processing and it used to process the data. So this is a flow. You are going to give an input stream and then we are going to apply continuous streaming process to get the output stream. So here we will be collecting data from application, sensor and other devices, and we have 4 modules like event producer, log queue and then streaming application and then result publishing and serving. So in the first module we are going to collect the data from application, sensor and other IoT devices and then we will be passed that into the event queue and then it will be all the queries will be processed using a stream processing application and it will be stored in the databases. So what is Apache Flink? So this is a general definition. It is an open source stream processing framework and distributed processing engine developed by Apache. So what are the benefits of Apache Flink? We have lot of benefits like it is a powerful, fault tolerant and expressive data processing capabilities. So it combines both the strength of batch processing and stream processing, in which means it will deals with both historical data as well as the real time data to process the application. So here we will discuss about bounded data stream and unbounded data stream. So bounded data stream will have a definite starting and ending. So here we will process one batch jobs or multiple jobs at a time. So here Apache Dataset API is used to process the bounded data stream. So unbounded data stream doesn't have any starting or ending. So it will just read the data and process the data right away. So here data stream API is used to process the unbounded data set. So Dataset API is used for processing the unbounded data set and data stream API for processing the bounded data set. So these are all the components. So here in Apache Flink it doesn't has its own storage. Instead it uses external storage like HDFS, S3 and then Kafka, Cassandra or DBMS. So these kind of external data storage is used for Apache Flink. And next one is the deployment layer. So deployment layer will consist of components like Flink runtime, Flink client, Flink web UI, Flink distributed shell. So if you want to work with multiple nodes, then we need to integrate that with Yarn, that is yet another resource negotiator. And also others like Docker, Kubernetes is also used to process if you want to work with multiple nodes. And here you are going to collect the data, that is data like transactional data, log data that is collected from log, IoT devices, click. All the data will be collected and it will be passed to the event queue and also stored in a database and it will be processed using an Apache Flink. All the queries will be processed using an Apache Flink and it will be stored in the databases. So here we mentioned that it is an Apache Flink. So what is happening inside the Apache Flink? That we will be seeing in the next slide. So here this is what happening inside the Apache Flink. How we are processing the queries, it consists of 3 modules. That is here as like the same way we are collecting data from transaction, log, IoT devices and it will be passed through the event queue and also stored in the databases and the query is processed using an Apache Flink. Here it deals with 3 parts. That is event driven applications. Here we will be accessing the data locally instead of taking the data from the remote location. Streamlined processing in the sense here all the ETL job like extract, transfer, load jobs will perform the same functionality like transforming and enriching the data and storing the data from one location to another using a continuous streamlined process. So in that and all the stream and batch analytics in the sense batch data will deals with Dataset API and stream data will deals with data stream API. With the help of that we are going to process the data and it will be stored in the databases. So next we are going to see the architecture of Apache Flink. So here Flink kernel is a major component of Apache Flink. So the execution engine will perform and handle all the tasks that is submitted to that. So Apache Flink will follow master and slave architecture. So it will have one master and multiple slaves will be there, and it consists of job manager and task manager. So job manager is responsible for managing and scheduling the jobs submitted to it, and task manager is responsible for executing the jobs. And Apache Flink Ecosystem. So Apache Flink is not only a data processing tool, also it consists of lot of tools and library embedded with it. So here we'll have Dataset API. Dataset API is used for batch processing. Here we can perform operations like map, reduce, iterate and join. And Data Stream API, it allows us to create arbitrary operations on the event. And then it consists of multiple libraries like CEP, Table and SQL API, and then Jelly, Table and SQL API again, and then Flink ML. So these are all the libraries that are incorporated in the ecosystem. So what is CEP? So CEP is a complex event processing. So here we are going to create a pattern for all the event and we are going to process that using a regular expression. So that is your CEP. And then Table and SQL API. So here we are providing API for SQL and table. So we are going to write a query in a SQL and store that in a table, and we are going to manipulate the data using a table schema. So that is your Table and SQL API. And next one is Jelly. So Jelly is a versatile graph processing tool. It is mainly used for analyzing the data and then processing it in the form of and representing it in the form of graphs. So that is Jelly. And then Flink ML. So Flink ML is a distributed data processing machine learning library. It supports both supervised and unsupervised algorithm. So supervised and unsupervised algorithm means like logistic regression, linear regression, decision tree, k-means, all the algorithm will be supported by Flink ML. So this is the overall architecture or the overall ecosystem of Apache Flink. And this is a Flink Layered API. So we have three layers. The first one is high level analytical API, and then stream and batch data processing, stateful event driven application. So these are all the three layers of Apache Flink. So what is there in the high level API? You have all the SQL and table API will be there. So here we will be providing API for SQL table and used for processing the SQL queries. And then stream and data processing, we have Data Stream API. So you are going to deal with the continuous data and the real time data, then you can go for a Data Stream API. So what it will do? It will assign an arbitrary operations on the incoming events. And then stateful driven application. So all it consists of a process functions like event, state and time. So what are the event that you are going to process? State and the time information will be incorporated in this layer. So this is your Flink Layered API. We are going to see the key use cases of Flink wherever we are going to apply Flink. So event driven application. So event driven application in the sense if you want to work with a real time data, we are going to use Apache Flink. So here instead of getting the data from a remote location, we can access it locally. So that is your event driven application. Continuous data pipeline, the same. If you want to perform an ETL job, then all the functionalities of transforming and enriching the data with the help of continuous pipeline process can be applied. And then all real-time application can also use of Apache Flink. And machine learning algorithm, as we already discussed, it supports supervised and unsupervised machine learning algorithm like logistic regression, linear regression, k-means. So that also applicable with the help of Apache Flink. And also graph processing. So we have seen a Jelly, that is a library which is used for graph processing. So these are all the key use cases of Apache Flink. And here we have a comparison between the periodic ETL, that is extract, transform, load, and continuous data streaming. So here what we are doing, so in periodical ETL, the data will be read from the transactional database and we are going to process it and then we are going to write that in the traditional databases. And what is happening in continuous data pipeline? So all the events are ingested into the continuous application, and then in turn it will be processed and it will be placed in the event log, and also it will be stored in the database. So this is a comparison between periodical ETL versus the continuous data pipeline. So next we have a comparison between batch and a real time processing. So batch processing, here all the jobs are executed at once. So we are going to read the event and then you are going to process that with the periodical query application, and then we will be storing in the storage device like HDFS, that is Hadoop distributed file system, and also the report is being generated. And what is happening in the streamline analytics, we are going to generate an event and it will be ingested into the continuous query processing application, and then it will be updated into the data store. It will be telecasted in the live dashboard. So this is what happening in your streaming analytics. So this is a comparison between batch analytics and streaming analytics. So before we have seen a difference between the periodical ETL and the batch analytics. So these are all the advantages of Apache Flink. So it is a stateful stream processing, stream and batch processing, scalability, API support, fault tolerance and availability, low latency, high throughput, flexible data format and optimization. So these are all the benefits of using Apache Flink. So what are the limitations? Obviously if you have an advantage, there will be a limitation for any tool. So the limitation is steep learning curve can be achieved in Apache Flink. That is considered to be one of a drawback, and project maturity and community size is considered to be a drawback of Apache Flink, and limited API support is also the limitation of Apache Flink, and basic machine learning support. Here we will not providing any advanced support, only a basic machine learning support is given by the Apache Flink. So these are all the limitations of Apache Flink. So this is Apache Flink in ecosystem. So we are comparing a lot of tools like Flink, Kafka, and then HBase, HDFS. So here your Flink and Kafka. Here analytics on data in motion. So what is data in motion? So here we will be dealing with a real-time data. So Apache Flink and Kafka will be used for handling the real-time data. And there you have a HBase and Flink HDFS. So HBase and HDFS, here it is analytics in static data. Static data means discrete data, that is data at rest. So here we will be dealing with discrete data, and here we will be dealing with continuous data. So Flink and Kafka will be dealing with continuous data, HBase and HDFS will be dealing with the static data, and all the data will be ingested and will be processing your ETL jobs. So this is what the Apache Flink in your data ecosystem. So what we have seen so far is we have discussed what is batch processing. So we are going to collect the data, sort it, and then we are going to process it multiple times to produce a result. That is your batch processing. And stream processing system, here we will be dealing with continuous data, that is a real-time data. So data in motion. So in batch processing it deals with data at rest, stream processing will deals with data in motion. So that is your stream processing system. And then we discussed about the architecture and key component. So we have seen that Apache Flink will follow master and slave architecture, and we have discussed about job manager and task manager. So job manager will manage and schedule the job, task manager will execute the job. And then Apache Flink ecosystem. So that in that we have seen what is Dataset API, what is Data Stream API, what is CEP table, what is SQL Table API, and then we have seen what is Jelly, Flink ML. So the Apache ecosystem is not a data processing tool. It consists of lot of tools and libraries incorporated with it. That we have discussed, and also we have discussed the various use cases of Apache Flink and also the advantage and disadvantages of Apache Flink. So we have seen the brief about the Apache Flink, starting from definition, batch processing, stream processing, architecture, ecosystem, use cases, advantage and disadvantage. Hope you got a clear idea about what is Apache Flink. Thank you.